thank you, everybody. My name is Arun Gupta. I run the developer programs team at Intel, and I'm super excited to give this talk about GenAI recipes for cloud-native development. And today I have with me Kaushal.
Yeah. Hi, everyone. I'm Kaushal. I'm a distinguished technologist with Infosys. My core area seems to be AI, GenAI, AI platforms, and happy to be here. We'll talk more.
All right, let's dig into it. Why do we think cloud native is an ideal platform for AI? I mean, if you think about cloud native, over the last 10 years, a lot of companies have built a developer platform on top of that. And in terms of when you're offering different workloads on it, you want scalability. What that means is easy scaling of your compute resources up and down, because your loads are bursty. At some time, you need much more resources. Sometimes you don't need much more resources. And that is particularly true when you are looking at AI workloads. Sometimes they are taking days. Sometimes they're taking weeks, months, if you're training your models, which is much more longer task. But if you're doing inferencing, that is a bursty workload. So you need that sort of a scalability. You need cost efficiency. You want to start with a LLM, large language model, but then you may want to go to a small language model. So that cost efficiency that you're only paying for what you use, really. Containerization is a key element of it, because what it gives you is a workload across different compute environments. Whether you're running on cloud, whether you're running on edge, whether you're running on data center or on laptop, you don't want that impedance mismatch. And that's exactly what Harmony is about. Your test, dev, staging, prod, all of these different environments, they have exact same environment. You just scale up from there. High availability is critical, particularly for AI workloads. If your model is getting trained, in the middle of a training, which has been done for like 6 weeks, you don't want your cluster to go down, because if your cluster goes down, that retraining starts all over again. And last but not the least, as you're building your GenAI applications, you need that microservices architecture so that you can scale each and every different component accordingly. Now, if you're building a GenAI application, a lot of the customers are really looking at RAG, or Retrieval Augmented Generation. This is a typical architecture of a RAG, so don't get bogged down. But if I walk you through this, on the left side, what you see is your enterprise data. That could be sitting in Salesforce, ServiceNow, Slack, email messages, PDF documents, databases, wherever it is. You do some ingestion of that data. You put that into a data store. Could be a vector, could be a graph database, could be Elasticsearch, or wherever it is, with a vector index, so that it allows similarity search. Now, your query comes in from a user from the top. You extract the relevant information out of the query. You retrieve the information from the vector database. You augment it. You send it to the LLM. And then you generate the response, Retrieval Augmented Generation. So that's a typical RAG architecture. Now, you could use a LLM as it is, or you can fine-tune the LLM and then play around with that. Or you can use RAG. So these are different components in architecture. So essentially, when you are building your GenAI application, this is an architecture that you're looking at it. But now, if you start kind of breaking it down, what are the different components of a GenAI application? Well, you need a data prep microservice, which essentially takes your data, ingest it, chunk it, create the embeddings. Then you need a vector database. Could be an open source database, could be a closed database, could be a service. It doesn't matter. Or an existing database with a vector index onto it. Then you need a retriever. Then you need a re-ranker, which kind of re-ranks your responses based upon what you're looking for. And of course, you need an LLM or a SLM or whatever language model that you're using. And sometimes LLM are generic. Sometimes they are very tuned to a specific use case. But these are the different components that you need when you're really trying to build a GenAI application. As you're starting to compose your GenAI application, when you look at embedding, there's a wide range of embedding. I just want to build, I'm writing a Spring Boot application or a Go application or a Python application. How do I take that and convert it into a GenAI application? I don't know what embedding to choose. Ditto with vector databases. My source of truth lives in a Postgres or in a MySQL or somewhere else in a PDF document. What vector database should I choose? I don't know how to choose it. And ditto with LLM. There's a wide range of LLMs. Sometimes the LLMs require a GPU, but more often than not, it just works very well on a CPU. So what is my decision matrix if I'm choosing all of that? So effectively, if you want to build a RAG chatbot, you want to build a chatbot that takes care of your enterprise data, bring it in, and leverage that for a simple ChatQnA, then this is what your GenAI recipe would look like. This is one GenAI recipe. Meet OPEA. OPEA is Open Platform for Enterprise AI. This is a Linux Foundation project, belongs to LFAI and data, and it gives you GenAI recipes that can be deployed in enterprises. And that's the whole premise of it. It has pre-built recipes across a wide range of use cases that you think about, and is fully open sourced. And let's dig a little bit more into it. So what is OPEA? If you think about it. We talked about those different component-level microservices, right? So the first set is a framework of composable building blocks. Embedding, retriever, re-ranker, LLM, vector database. Those are your component-level microservices. Using those composable microservices, you can build end-to-end workflows. So ChatQnA is your end-to-end workflow, where you can compose these components together. Agentic systems, AI avatar. So you can build all of those end-to-end blueprints, recipes, workflows, whatever you want to call them as. And last but not the least, you need an assessment system for grading these GenAI systems. Oh, I built this blueprint recipe that's going to run on AWS, that's leveraging this particular LLM, this particular vector database, and so on and so forth. And what is my throughput? What is my time for first token, my second token, so on and so forth. So if I up-level from this description, what we are saying is OPEA consists of two components. One is a construction component, which is essentially your framework and blueprints. And on the right, what you see is an evaluation component. So construction and evaluation. Now, if we were to translate that into the GitHub repo, github.com/opea-project is a GitHub repo. It's a GitHub organization. Again, it's a LFAI and data project, so fully open source in that sense. On the top right, what you see is a GenAI comps. That is your component-level microservices. Each of those component-level microservice, whether it's an embedding or a retriever or a LLM or a vector database, is a cloud-native component. Essentially, it has a Docker container that is sitting in the Docker Hub. GenAI examples, on the other side, are your ready-made blueprint recipes. And those are available either as a Docker Compose. So you could say, show me a Docker Compose file for ChatQnA. And voila, you have it there. So that's the way it works. And ChatQnA is just one example, and I'll talk through some of more. And on the bottom left, what you see is a GenAI eval. This is the evaluation framework that I was talking about earlier. It gives you tools by which you can evaluate how your GenAI recipe look like in a particular combination or a configuration, whatever works for you. So let me show you a little bit on the GitHub repo how these look like. So here I am on the GitHub repo. Let me make the font slightly bigger. So when I look at GenAI comps here, when I look at the comps component here, this is where all my components are sitting. So this is where you can see my code, my data prep, my embedding, my fine-tuning, my guardrails, LLMs, LVMs, all of these component-level microservices are sitting. If I go to LLMs, then it says, OK, what kind of an LLM do you want for a particular use case? Let's say I'm looking for text generation. Then it says what kind of text generation LLM you're looking for, whether you're looking for Ollama or TGI or VLLM, and multiple other integrations are getting planned. So that's that. If I go back to components again, actually, and comps, and I look at down here, vector stores, you'll see a wide variety of vector stores that are already available as a component-level microservice. Okay? Now, if I go back to OPEA project, I look at, say, GenAI examples. These are about 20+ ready-made GenAI blueprints that are available to you. So let's say if I look at ChatQnA, it kind of gives you your Docker Compose, your Kubernetes Helm charts, single click. You can fire up a Docker Compose and say, run it in my local environment. Docker Compose is really good for experimenting and playing with how your Docker images are really behaving with each other. So if I go in here, and I say Intel, because it needs to be specific to a hardware, I want to deploy it on Intel CPU on Xeon, which is the most prevalent CPU across different hyperscalers. So now I have a compose.yaml here. And in here, these are all my services. So you can see Redis vector database, my data prep service, my embedding service, so on and so forth. And the beauty of all of this is I have a compose.yaml. I can just swap out my LLM. My default LLM is TGI. But now I want to run that exact same thing with compose VLLM. So everything in my compose YAML stays exactly the same. I just replace the TGI service with VLLM, and there we are. Similarly, if I want to run it with Pinecone, which is a managed service. Now, this is an open source project, but doesn't mean it only integrates with open source vector databases. So now, instead of data prep Redis service, I have a data prep Pinecone service. So it's very streamlined in that sense of what your choice is, but it gives you an opinionated stack as well. So as I just explained, we have 20+ recipes that are available in GenAI examples. I just showed you one of ChatQnA, but there is a code generator, code translator. There is a agentic Q&A. There is a graph RAG, where you want to use graph as a backend database. There is a video Q&A. There is a visual Q&A, FAQ generator. Give it a bunch of documents and say, generate a FAQ for me. So these are simple use cases that we have seen customers deploying in practice. And the beauty of this is because GenAI components and GenAI examples are open source, so you should be able to take a look at GenAI components and create your own GenAI examples. So I would love to see, frankly, what GenAI examples that you are saying and create your own recipe and contribute to GenAI examples. Now, OPEA, Open Platform for Enterprise AI, is a 100% open source project. And so it is run by a technical steering committee. And Intel is the primary maintainer right now. And I'll tell about some really useful stories here. So we have 2 people from Intel on the technical steering committee. But as you can see, the diversity over here, there are lots of good end users and vendor companies that are part of it. And the one that I'm particularly excited about is AMD. Now, when we build these GenAI components, when we build these Docker images, they're, of course, created for Xeon and optimized and validated on Xeon. But AMD, becoming as part of the technical steering committee, have been contributing their hardware to the CI/CD pipelines. And what that means is they're validating these samples on the AMD hardware as well. So that's pretty awesome, actually. Let's take a look at the rich ecosystem of partners that we have built over the last 8 months or so. When we started the project, there were about 14 launch partners. Over the last 8 months, I'm very proud to say that we have grown up to 45+ partners. And by the way, this chart is already outdated. I built the slides, 2 days ago, and 2 more partners have joined since then. Let me talk about some of the examples here. So AMD, I already talked about how they are contributing their hardware to the CI/CD pipeline. In your company, if you are building GenAI blueprints, you have to figure out, where are you running them? Which hyperscaler you're running on? Which hardware you're validating on? With this, the OPEA ecosystem is doing the validation on Xeon and AMD. And there is a wonderful effort that is going on within CNCF. There is an AI/ML working group. Within that, we are also working on validating these samples on ARM architecture. So do you want to run all of that validation by yourself, or do you want to leverage the work that is already happening in the OPEA project of taking these GenAI examples that are getting validated on different hardware architecture and different hyperscalers as well? ArongoDB is a graph database, and we have been working very actively with them to do that data prep, ingestion, and the backend for a ChatQnA example here. Canonical, we all know, is a company behind Ubuntu. We have been working with them to do the integration in their micro-K8s, which is a full-blown Kubernetes cluster that they create, integration over there. We have been working with Docker, because all the images are published on Docker Hub. So how do we make it more visible, more streamlined workflow over there? We have been working with Infosys. Kaushal is going to talk about some wonderful work that we've been doing with them. We've been working with MariaDB, how we could use MariaDB as a backend vector database. So we've been working with MinIO, same thing. MinIO is your storage platform. Throw any unstructured data on it, terabytes, petabytes of data, and how we can leverage MinIO as a backend database. MongoDB, again, you don't have to have a vector database. MongoDB would work fine as a backend store. Neo4j is a graph database, working with them on a very similar element as well. Prediction Guard is a partner that have actually contributed guardrails to the project. You are leveraging a LLM, but before you send information to the LLM, you want to make sure that there is no PII that is leaked out. So that's the kind of guardrails that Prediction Guard has contributed over there. The list goes on all the beautiful work that we have been doing, a wide range of partners over here. With that, I'm going to bring Kaushal to the stage.
Thank you. Thanks, Arun. So I'm Kaushal. I'm from Infosys. And one of the key things is we have the most demanding customers. And I'm not talking about our customers, but our own employees. So we have got about 300,000 people looking for various information, HR policies, travel policies, past RFPs, sales documentation, a lot of knowledge article. So there is a lot of knowledge that has been created inside Infosys, and also there are a lot of people looking for it. So we started our journey on AI around 2016 onwards, when the Spark ML, all of those things were coming up. From there on, GenAI just made it worse. So one of our key things on AI is to be an AI-first organization. What do I mean by that? Is basically eating our own dog food. That means whatever we do for our customers, we do it first for ourselves. So we have an award-winning platform. We call it InfiMe, which is like a sort of an app or a website, or any internal experience is managed by one big live platform. Right? And there are about 300,000 users using it at any point of day. So what we did is we created a Copilot sort of experiences. So for example, if you look at Word documents, so today you would have seen Microsoft Copilot. Now Microsoft Copilot can tell you everything that is out there on the Google, but it doesn't tell you about what's inside your organization, what is your knowledge, etc. Right? So whether it's a Word document, it's a PPT, or it's just a website or a chatbot on your app. Right? So what we did is we built all these knowledge sources, indexed those documents. A lot of, as you can see, right, the indexing those documents, etc., is a lot of work. So for example, a lot of our proposals or RFIs, responses, etc., we would like to save. Now it has a lot of sensitive information. It could be a PII information, it could be a financial information. Then you have different departments, as any organization would have. So how do you manage the data security, etc.? All of those challenges that we do. One of the key things, you might wonder, why OPEA? So for us, we are a cloud-native organization, so we build our own stack. A lot of it is on NVIDIA H100 clusters, as well as we also use internally Intel Xeon CPUs and a lot of other hardware, right? So we wanted something which was cloud native, something we can put. Some of our things are on cloud, some of things are on-premise. So we wanted a good balance between a hardware and where we can deploy stuff, right? So Kubernetes is the right example, microservices is the right architecture. And then we wanted something that we can extend. We don't want to buy a product. We want to extend it. We want to build it. And we want to create our own offerings on top of it, right? So with that, now we are in a pilot phase where we have about 100,000 users using this. Now the challenge is to how we can optimize some of the experiences, including multi-model capabilities. Could be a speech, could be a images, could be a video, etc. Right, so that's where the next challenge is. Interesting part is we are using Elasticsearch inside as our vector database. What I'd like to say, I'll just take a slightly tangential issue as to why Elastic, right? So with GenAI, with vector DBs are a new rage. What we realized at the end of the day is we needed a cluster big enough for our own information, index it, performant, and something that we are comfortable with, right? And with Elastic, we really got lucky because we were upgrading Elastic around 8.7, 8.9 version, where they started introducing a lot of vector-related things, right? Key updates on there was hybrid search, which is really important. I'm not sure whether you guys are able to see the numbers, but we ran some experiment inside where we created some synthetic data, like what kind of questions, answers people would like to see on our application, right? So we ran multiple benchmarks, evaluated, and typically what Arun explained, right? There is a retrieval, there is a re-ranking, and then there is a generation. So you are calling 3 APIs at least, right? Don't forget the call to the vector database, etc. So when we did that, we actually realized that even though you can run a re-ranker and get a better accuracy, but with hybrid search, right? So if something like BM25, what Elastic uses internally, as well as with a dense search, which is your embedding vector, it really gives you a good accuracy, right? So we could shave off probably a 2-second call of a re-ranker model internally. Right, on top of it, Elastic definitely provides a lot of enterprise functions in terms of the data security, the ACLs for your user group management, etc. And one of the, I think the last point is we got really lucky because Elastic introduced vector APIs in the Java stack, right, in around 2021. And that AVX instruction set, which can really work on Xeon Emerald and Xeon Rapid Sapphire. So using those instructions, your searches becomes really faster. You can imagine the embedding vectors can size from anywhere from 60 dimension to 1,000 dimensions. So it requires a special hardware and a special instruction set in order to make it more performant. So we did those changes. All of that is merged as a PR in the OPEA. And finally, a lot of our customer loves Microsoft Azure. So what we are putting is a similar offering on Microsoft Azure. Basically, it's a set of Terraform template or ARM templates, as you would like to call it. Come in, deploy it. We are adding things like Cosmos DB and the telemetry integration with Azure Monitor, so it really becomes Microsoft-specific offering. That will be listed on Microsoft in a few days' time, and I hope you guys can see it, use it. With that, I think we are good, and we'll take any questions if you...
we have a few more slides.
Yeah, oh, sorry.
If we take that whole paradigm forward, right, this would be eventually a one-click deployment on Azure. So click, and you get a ChatQnA up and running. Now, we have also done similar work with AWS Marketplace. So that's a QR code. If you scan that QR code, that takes you to a page which has the OPEA, Q&A, ChatQnA available on Azure Marketplace. And what does that offer? It's basically a Terraform-based OPEA recipe that is for a quick deployment on AWS. And what it is, I'm kind of showing the stack here. So we have the LLM. We are using TGI. As an embedding model, we are using TEI, again, optimized. And then as a vector database, we are using OpenSearch, open source project. And it's a straight-up deployment on Amazon EKS, which is their managed service. There is no tie-in, because even Amazon EKS is 100% upstream compliant in that sense. So there is really, even though it's a service, even though it's a marketplace offering, but there is no tie-in to any of the managed services, because you could run this on any Kubernetes cluster, and that would work very well. However, there are elements by which it is configurable. So for example, it is also integrated with Bedrock, which is their managed LLM service. By default, you can use Anthropic Cloud 3 Haiku, but there are other models that are supported by Bedrock that can be easily integrated. There are guardrails, there is Redis vector database if you want to choose and reconfigure your open source. So all of that fun integration is already available. In terms of the roadmap, what we did is we started the project back in April of 2024, of this year. We released 1.0 a couple of months ago. We released 1.1 a couple of weeks ago. And now we're continuing to work on 1.2, 1.3, and so on and so forth. And the thinking really is, one release, we're going to do a feature. The second one is going to be more of a stability and performance kind of a release. And then we go to a TikTok model. So then feature, and then stability, and so on and so forth. Now, the important part is, this is a roadmap that we have created, but being an open source project, it is required to be approved by the technical steering committee. So we propose the roadmap, but the technical steering committee is going to give a thumbs up, and that's when this roadmap actually becomes committed. So you the star on the top. Something else that I want to highlight is, AI software catalog, intel.com. And if that's the URL that you go to, you can see a lot of these samples available for you to play around with. And you can say, hey, I don't want to get into GitHub. I don't know how to play with it. Give me instructions and guide me through those steps. So this is where you can see some of those samples start appearing up. The intention really here is, this is something that we are playing with right now, but eventually we want to contribute this to the CNCF as an open source project. And within the AI ML working group, there has been discussions going on to create an AI playground. So this could potentially be the basis for creating that AI playground, essentially. If you want to get started with OPEA, now OPEA-project, it's a GitHub page, essentially. And we're creating a simpler redirect as well. But this is the best page for you to get started with. And smack on the top and in the middle, you see a getting started page. So I'm giving you a QR code here. From that QR code, you can deploy at least the ChatQnA example across 5 different cloud providers. Amazon, AWS, Azure, Google Cloud, IBM Cloud, and Oracle Cloud. And essentially, if you look at these instructions, what they give you is, hey, spin up a Ubuntu VM 2404, and on that, once you got the VM get up and running, then the steps are very similar. Basically, install Docker, set up Docker Compose, and fire it up. And if you want to run this, there are accordingly Helm charts available as well, which can easily get you started on Kubernetes. So that's the whole premise here. And the other work that I'm super excited about is that is happening in the AI ML working group within CNCF. So there is a strong opportunity for you to contribute and collaborate. So I would highly recommend joining the AI ML working group. There's lots of good stuff that is happening over there, particularly validating these samples on the ARM architecture. And the best part over there is you don't have to have an account. If you join that working group, we will give you an account, we will give you the ARM credits, and then we will give you the ability to play. All we need is you to validate and test those on the architecture. Take the sample, run it over there, file the bugs, contribute it. So a lot of people have been asking me, how do I start on my open source journey? This could be your open source journey. So with that, I think that's a wrap of our presentation, and we'll take some questions.
OK. So let me just repeat the question. What you're asking is, A, how do you select the right size model for your use case? B, what do you do with hallucinations, right? So I think, look, hallucinations are not bugs. They are features, right? I mean, it's just you are producing next token. You're predicting, right? So there is no right answer, can I reduce hallucination? But I'll tell you what we do, right? So we start with the benchmark first. I don't start with the model first, right? When we say data first, what do you mean by data first? Is we create the benchmark in terms of Q&A. As you saw on the slide, right? We gone through about 8 or 9 different models. just to see what is that model without even fine-tuning what level of accuracy that gives me, right? Now, in terms of your specific question, in terms of what is the size of the model or the parameters, right? So when you talk about embedding model, right, there are some really great embedding model from BGM3 are very small. They can be deployed on CPU, so you really don't need an expensive hardware. They can range anywhere from 1 million parameter to about 1.5 billion parameters. And in terms of generational model, right? So generational model, you have to figure out what is your use case. So typically when you need an agentic kind of a behavior where you are creating a workflow, where you are doing some level of reasoning, etc., that's where the model tend to get bigger, right? So for a typical basic fundamental RAG use cases, anywhere from 3 billion to 7 billion parameter model should be good enough. I think that should be the thumb rule you should go with. So, okay. So again, your question is, what is the size of the data that you need to fine tune, right? So that's a most asked question actually in AI. But if your domain is not very specific, I suggest not to fine tune with, first thumb rule. Second is whatever base model that you have selected to fine tune, right? Look at what are the scaling laws that model is using. So for example, how many tokens per parameter sort of a thing, right? So probably I think we have broken the chinchilla laws long back. So typically look at that as a hint. And then over a period of time, I think you need to understand one thing, that all gen models, and don't quote me, but all gen models are overfitted. So more data, better it is. And if you use something like PEFT, you can really play with your parameters. So you can play with metric rank, right? 8 is recommended. If you don't have much data, I suggest don't fine tune. Because basically, if the domain is understood by the base model, RAG is there for not for you to fine tune. So unless and until you have an absolute need to fine tune, don't do that.
I think the two recommendations that we give to our customers is, first is, exactly on those lines. You got to really think about what is your end case. RAG usually works a lot better, and data is the oil, right? Data is one that keeps it going. So the more data you provide, the more context it has, the more it can create the connections. I think the other point that Kaushal briefly mentioned is, you don't have to go for like a 405 billion parameter model, right? 1 to 7 billion is 1 to 5 is actually a pretty sweet range if you have enough data that is generating the context for you. And usually those models really very well work on a CPU. And if you look at the OPEA story that we were talking about, this is all about inferencing, right? It's not about training. Kubeflow is more about training and kind of that stuff. But once your model is ready, then you bring it in here, then it's a pure inferencing story. And that's why OPEA runs very well on just a sheer CPU itself. But if you have GPU and you want to leverage that, that capability is there too. Yeah, absolutely. So as a matter of fact, some of our customers are actually working with OpenAI as the backend. And one of the integrations that we have done in the AWS Bedrock with using Amazon Bedrock is how you can use Anthropic Claude 3 as a backend model. So it's not restricted to, by any means, just to open source model. What we are seeing is, for example, customers start with Azure OpenAI. It's very good for them, very quick for them to get started. As the app becomes more popular, the cost significantly rises up. So what we are seeing is migration away from Azure OpenAI, because end of the day, if you see OpenAI is a wrapper around a vector and an LLM and an embedding and a retriever, all of that is hiding behind a single API. So we have been working with customers where we are migrating them from Azure OpenAI to straight up Azure Compute. And so they have compute, the cost is a bit more under control, and then all of those components are existing in OPEA already. And then, most importantly, you have the data in your control, in your jurisdiction. They don't want to send it to OpenAI at all because certain countries, for example, if you look at sub-Saharan continent, they have requirement that the data cannot leave the continent. So those are some of the advantages that we are seeing moving away from closed models to straight-up OPEA.
You mean general challenges? I think adoption and the behavior. So human behavior is very different from, you can use a chatbot for having fun with a model and all of that, right? But when it comes to business, how do you believe it? What chatbot is saying, right? So how do you adopt? What is your adoption patterns? What is the right way to do it, right? We always talk about in-flow applications, right? So that is something that we are doing in Infosys, where a lot of plugins are built on existing app rather than like, for example, a lot of our code generation related stuff, right? Because we are a big tech company. So we have open source model with our own plugins developed for Eclipse, IntelliJ, etc., where we can enable these experiences. The other things are in terms of compute. At one point in time, we were limited by compute, and thank God Intel and AMD have come up. So that's one of the things was restricting factor for a lot of customers to adopt things faster, move on, etc. And I think the industry per se is growing very fast. So for example, within RAG, if you see, there are tons and tons of patterns, and that's where you see so many examples that we have in OPEA, right? So there are so many patterns. So for example, one of the things that we in Infosys trying to do, like somebody asked a question, what was the operating margin difference between 2024 and 2023, right? In that case, you are actually doing 2 queries from that one single question, and then combining the answers of 2 queries and then finding out the differences. So there are so many patterns that exist today. Some were there in LangChain, some is there in Llama Index, somebody has written their own papers, etc. Right? So how do you create a blueprint for enterprises so that you are not repeating the same thing over and over, right? So, and that's where OPEA makes a great impression.
All right, that's the time up. Now we're going to hang out by the stage if you have any more questions. Thank you.